Let me welcome all of you to our third President's Distinguished Lecture and the first in the current academic year. Some of you, I notice, have become regulars, and I attribute this to the quality of the lectures and the stature of the speakers that we have successfully invited to Stevens. As you all know, the primary purpose of establishing this lecture series was to create an environment where we can have a substantive discussion about significant issues in science, technology, the societal implications of science and technology, and the related public policy issues on some of the more important issues that all of us should be interested in. The idea was not to go into the minutiae and to the nuts and bolts of a particular technology, but to discuss issues at a very, very high level. We've been extremely careful in selecting our speakers, in ensuring that they are known to be an authority in the field where they will speak, and that they keep the level of the conversation at a sufficiently high level. Our first speaker was Norm Augustine, who was here approximately a year ago. Our second speaker was Dr. John Holdren, the President's Science Advisor, and I am especially delighted to welcome our third speaker today, Dr. John Deutch. I do want to say, before making the introductory remarks, I do want to say that I personally have been very interested in some of the recent developments in the area of energy. Energy is an issue that concerns really every American citizen, and in the past couple of decades there have been fairly significant science and technological developments that have resulted in a plethora of activities in oil and gas exploration and production. And these issues actually do come with a whole host of related public policy conversations. In fact, they introduce an appropriate level of controversy. And I think this topic is particularly suitable for a discussion in the President's Distinguished Lecture Series because of the kind of controversial issues that they invite. And these are the kind of issues that universities should be engaged in. These are the type of issues that university professors, people from the corporate world, and of course our students should be excited about. So in order to find the right person to come to Stevens and speak about these issues, I had to do a lot of homework. And I contacted a host of individuals that I know who are very well connected. And I must say that at the end, all indications that I received pointed to one individual. And that was the gentleman who will be our speaker today. And unfortunately, I personally did not know Dr. John Deutch. So what I had to do was to go to the former Secretary of Energy, Dr. Steve Chu, who was here, if you remember, about 2 years ago and gave a lecture himself, and asked him to make an appropriate introduction. So I'm grateful to Dr. Chu for making that introduction. But I'm especially grateful to Dr. Deutch for agreeing to take time from his busy schedule. And Dr. Deutch, I would like to apologize in making your biographical sketch much, much, much shorter than it should be. I figured, in fairness to you, I can't spend all of the time that we have allotted to your speech to summarizing your illustrious resume. But let me share with you some of the highlights. Dr. Deutch is an institute professor at Massachusetts Institute of Technology. He's been a member of the MIT faculty since 1970 and has served as chairman of the Department of Chemistry, dean of science, and provost. And he just mentioned that he likes provosts and he has a lot of respect for them because of what he's gone through himself. For your information, I used to be one once upon a time. Dr. Deutch has published over 160 technical publications in physical chemistry, as well as numerous publications on technology, energy, international security, and public policy issues. As such, you are really the perfect person for this lecture series. Dr. Deutch served as the director of the Central Intelligence from May 1995 to December of 96. From 94 to 95, he served as Deputy Secretary of Defense and served as Undersecretary of Defense for Acquisition and Technology from 93 to 94. He served as Director of Energy Research. He also served as Acting Assistant Secretary for Energy Technology and Undersecretary in the United States Department of Energy. These are over different periods of time, and in the interest of time, I am not mentioning all the time periods. In addition, Dr. Deutch has served on the President's Nuclear Safety Oversight Committee, the President's Commission on Strategic Forces, the White House Science Council, the President's Intelligence Advisory Board, the President's Commission on Aviation Safety and Security, the President's Commission on Reducing Protecting Government Secrecy. He served as chairman of the Commission to assess the organization of the federal government to combat the proliferation of weapons of mass destruction. He was a member of the President's Committee of Advisors on Science and Technology. He received the Aspen Strategy Group Leadership Award and was the Phi Beta Kappa Orator at Harvard University in 2005. He's a member of the National Petroleum Council. In 2009, he received the MIT Gordon Billard Award for Special Service of Outstanding Merit performed for the Institute. He's a member of the Secretary of Energy Advisory Board. And just so you know, he earned a Bachelor of Arts in History and Economics from Amherst College and a BS in Chemical Engineering and a PhD in Physical Chemistry from MIT. He holds a number of honorary degrees from various universities. He has served as the director of, among many companies, the following: American Natural Resources, Citigroup, CMS Energy, Cummins Engine, Perkins-Elmer, Raytheon, SAIC, Schlumberger, and some additional companies. I am going to skip all of the incredible recognitions that you have received from every possible government agency. And I would like to ask the audience to please join me in giving you a huge round of applause and welcome you.
Thank you, Mr. President. If that's what you call a brief biography, let me tell you, it only serves one purpose, and that is to underline how old I am. And hopefully it will make you forget the fact that he says I'm controversial. But I'm very pleased to be here. I'm very pleased to be the third distinguished president's lecturer. I want to leave you with a couple of facts about what associates me with those people. First, Norm Augustine and I have exactly the same birth date. We were born the same day. Secondly, John Holdren wouldn't be where he is now if he hadn't passed the chemistry course I taught him at MIT. I want to speak to you about four aspects surrounding unconventional oil and gas in this country. The first is the staggering changes it has brought to the energy outlook of this country in just a very brief period of time. That's highly unusual. In the 50 years that I've been following energy matters in this country, it is certainly the most abrupt and massive change in energy outlook that I have experienced. Second, I want to speak to you about the economic and geopolitical consequences of this revolution in unconventional oil and gas production. Third, I want to speak to you about the one single serious matter that can derail the prospects of unconventional oil and gas for both the United States and for the rest of the world, and that is how are we going to manage its very, very serious environmental impacts. And finally, I want to spend a few minutes about the lessons that this recent history of a complicated science and technology issue has for universities especially for universities such as Stevens or MIT that have a strong technical character. So those are the items I want to cover with you, and let me begin by asking you to go back 5 short years, beginning of the Obama administration, and remind you what was on the energy agenda of the country at that time. First and foremost, it seemed like the United States was hopelessly dependent on imported oil. It had been for decades, and it looked like this country was going to be dependent on imported oil as growing in expense and with all of the geopolitical implications that had for the foreseeable future. Moreover, the drop in production of conventional natural gas in the United States indicated that we would have to import natural gas in increasing quantities, and the Energy Information Administration of the Department of Energy projected that by the year 2015 we would be importing 25% of our natural gas from abroad as liquefied natural gas in tankers at very high expense in the range of $10 to $15 per million British thermal units, BTUs. Secondly, the United States was embarked upon a major legislative initiative to adopt a greenhouse gas policy for the country. There was discussion about introducing a rather complicated, esoteric cap-and-trade system to reduce the emissions of greenhouse gases, particularly carbon dioxide, through a legislative proposal of setting a market for the amount of emissions that could be managed, and if you couldn't do that, you would have to pay a fine and pay that into the government. That was assumed that that regulation would establish a policy for the United States on greenhouse gas emissions. Third, there was an accompanying expectation of a renaissance for the nuclear industry. The nuclear industry looked like it was on a promising track, both in this country and elsewhere, especially because it was a carbon-free electricity generating technology. And finally, from the money that was raised by the government for selling permits for the emission of CO2, $15 billion a year would be available for research and development and demonstration of renewable energy technologies. That was the outlook, the agenda of the country 5 years ago. What is the outlook today, and how has it changed? First of all, there has been no progress on carbon legislation in this country since that time. And no one expects that the Congress of the United States will enact a legislation to control the emissions of greenhouse gases or to address climate change. Indeed, the President has indicated his intention to rely on environmental regulation by the Environmental Protection Agency under authorities provided under the Clean Air Act. Secondly, nuclear power is off the table. It is not going to happen. It will happen in a few countries. It will happen in China, happen in Korea, maybe 1 or 2 other places, but not in Europe or the United States or elsewhere for 2 reasons. First of all, the Fukushima accident, which once again raised in the public's mind and in our political leadership questions about the safety of nuclear power, but also its costs have continued to elevate relative to the alternative of other electricity generating technology. Finally, I note that the budget outlook is such, in the absence of sale of permits for CO2 emissions, meaning that there is not that $15 billion a year for renewable energy R&D that was anticipated 5 years ago. But the big news is something else. The big news has to do with the huge and unexpected growth in unconventional oil and gas production and resources, both in this country and in North America generally. Instead of anticipating imports of natural gas, we now anticipate that by the year 2015, 25% of natural gas consumption in the United States will come from unconventional gas production. During the same period of time, in the 5-year period, the price of natural gas has dropped from $8 to $10 per million BTUs to $4 or even less per million BTUs, a drop of a factor of 2. The low-cost natural gas has pushed into the electricity sector so natural gas is the technology of choice for generating electrical power in this country and in many other countries for the foreseeable future. Coal has reduced its presence in the electricity sector by 20%. Nuclear power is gradually, as the plants decline and their lifetimes expire, becoming less and less of a presence. And the low-cost gas has always also prevented renewable electricity generating technologies like photovoltaics to enter the market. So all of this has been a tremendous change which has benefited, had economic benefits and geopolitical benefits from the presence of considerable additional resources than were anticipated, especially of gas, but also of oil. Let me talk about the economic consequences of this great prosperity that was unanticipated. First, as I mentioned, there was the low-cost price of gas from a wholesale value of $8 to $4 per million BTUs, meaning that U.S. consumers, especially in the Northeast, were spending less for heating their homes, electricity costs were going down, and the price of producing chemicals in this country were going down. Secondly, there has been an enormous increase in jobs in the domestic oil and gas industry across the country, from North Dakota to Pennsylvania, from the great generation of drilling that has taken place in unconventional oil and gas, and no longer are we importing those resources which would represent jobs in some other country. There's an enormous incentive now to look at natural gas technologically, to introduce it as a replacement for liquid fuels wherever they may occur, because liquid fuels such as motor gasoline are so much more expensive. And even though gas has gone into the power sector, the big opportunity, which hopefully will come with time, is the introduction of natural gas either directly as a fuel for light-duty vehicles, transportation vehicles, cars, or perhaps through conversion of the gas to liquids to some other fuel, even methanol, as a fuel for automobiles. So this is a tremendous change and a tremendous set of economic consequences which have been of benefit to the U.S. economy in almost all respects. What about the international consequences? These are equally important. For a person of my background, energy has always had an important element of international and international political implications that deserve and require attention from our country's leaders. First point to note, and it's an important point, this is not a U.S. revolution. It is a North American revolution. Canada has been a joint partner all along the way in the production and the resource development of these unconventional oil and gas resources. Mexico has huge resources itself, and the current president of Mexico indicates that he wants to modernize their oil and gas industry to take advantage of these opportunities as well. And another thing which points to the strength of the U.S. industry is we really have an integrated oil and gas market through Canada, the United States, and Mexico, an integrated North American market not caused by government, not caused by Washington, D.C., but the importance for businesses of making sure that they could move this resource which powers so much of the country, oil and gas, around the country. So it is a victory for North America and North American integration, a very strong example. Why has it happened here and not elsewhere? The good Lord did not put down unconventional oil and gas resources just in North America. They're all over the world. But they happened here first for two reasons. One is the enormous energy, controversial as it may be, of private ownership of oil and gas resources under your land that you own. In almost every other country of the world, if there are oil and gas resources under your property, the government owns it. And therefore, there is not a harmony between exploiting those resources on your land or in your community and you making money. That's the first point. And the second point is there is enormously greater intensity of drilling rigs and drilling rigs resources and drilling know-how in the oil and gas industry here in the United States, which is simply not matched anywhere else in the world. If you leave out China, the United States has something like 70% of all the world's drilling rigs. And as I will show you momentarily, those drilling rigs are the key to the technical advance that permitted hydraulic fracturing to take place. Two features. One was the ability to have rotating, steerable drilling, which allowed you to put the drill bit where you wanted it to be 4 kilometers from where you started to within a distance of a very few meters. Unbelievable control over drilling. And the third was this act of hydraulic fracturing, that by perforating the well along the way and injecting huge amounts of water into the surrounding rock, you fractured it and released the oil and gas that was present in tight sands or in shales particularly, much more being present there than had been expected. And you could do this in a very economical way. Those technical advances occurred in this country from the industry in this country, not only big companies, but small companies as well. And that's why it's not happening as rapidly elsewhere in the world, but the resource is present. So you can expect that over time, this unconventional oil and gas activity will spread to Latin America, for example, in Argentina and Colombia, to North Africa, in Tunisia and Algeria and Morocco, to Europe, where there are vast deposits, in the UK, France, Eastern Europe, and Poland and Bulgaria, in Russia, in Asia, particularly in China and India. So these resources are present throughout the world, and it has changed the circumstances from an expectation that all the oil and much of the gas is in the hands of a few major resource holders to a much broader range of countries and of people. That's terribly important in terms of the geopolitical relationships between consuming countries, such as our European allies and ourselves, and our producing countries, not all of whom are the greatest friends of the United States around. So this has been a tremendous benefit to U.S. foreign policy. The U.S. is going to be much more influential in global energy markets, and many of the countries that we're concerned about have faced a huge adverse wealth effect from realizing that their reserves no longer have the value that they used to have. Iran is the largest holder of conventional natural gas reserves in the world. Suddenly the price of their gas the value of their gas is much less than it was before. Russia was exporting gas to Western Europe at $10 per million BTUs, while the price in the United States is 3 or 4, and there's companies are talking about exporting our gas from North America, if not from the United States, and exporting our oil to these countries to bring them the benefits of diverse source of supply at lower costs. So all of this, it does put instability into these countries. There may be countries like Saudi Arabia, Iran, Kuwait, Venezuela will see falling revenues from their resources, falling wealth effects. It may put strains in their country and instabilities that may even lead to conflict. But the fact of the matter is the balance of power has shifted from those supplying countries that were most of the undemocratic supplying countries, which were of such concern to us, to other parts of the world which are of greater interest to the United States and its allies, to Europe, to Japan, the large importing developed economies, but also to rapidly emerging countries such as India and China who need energy for their growth, and it has shifted the balance in their favor compared to what it was 5 years ago. Well, there's some huge uncertainties here, huge uncertainties that should be of interest to engineers because it is also opportunity. The first is the world today consists of 3 gas markets. One in the United States where you can buy your gas at $3. One in Europe where you have to negotiate with Russians, get it for $10 or $12. And a third in Asia, where it's really substituting for diesel oil, not for coal, like it does in the United States in the power sector. In Shanghai, or in Singapore, or in Tokyo, you have to pay $15 to $18. Will that those three different geographical markets continue? Or will there be a gradual, not sudden, but a gradual moving through longer and longer pipelines, through more and more LNG tankers? Will there be a gradual harmonization of that to a single global price for natural gas, ex-transportation? That would have a tremendous implication on what has been a division of the world into three different markets. Huge, huge. Second point is, at the present time, the cost of gas in the United States, $4 per million BTUs, compares to oil at $100 a barrel, it's somewhere in the vicinity of $15 or $18 per million BTUs. There's the greatest disparity between natural gas and oil costs today in this country that has ever existed in history. And that means that there's a tremendous economic incentive for technology to find ways to make that natural gas substitute, whether it's in the transportation sector, whether it's in the chemical industry, anywhere to substitute for petroleum as a feedstock. So those are the two big uncertainties which are out there, uncertainties which also provide opportunities for technology innovation. But the largest question has to do with, will the public agree to seeing this kind of exploitation go forward because of its environmental impacts? And I'm sure everyone here in the audience knows that the controversy in the United States over this use of unconventional oil and gas is extremely strong, very equally divided, and by no means decided. So the question about how we manage those environmental impacts going forward is key to whether we'll be able to enjoy these opportunities I've spoken about, and also key for other countries, because other countries will look to the United States on how they've managed these environmental impacts and how they've managed the stewardship of the resources. Now, at this stage, I wasn't going to do this, but I do think I have time, I hope I have time, to show you a few slides to underscore some of the points I've made. So here is a map which just shows you where these resources are located. And it underscores the point I want to make to you. This is not happening in Texas, Oklahoma, and Louisiana. This is happening everywhere. North Dakota being in the Bakken up there. Secondly, you can see that it is everywhere in North America, in Canada, in the United States, and in Mexico. And every time they draw this graph, there are more places which are located on it because there's been more exploration. So it's a North America phenomenon. Here's the chart as it exists today for the world. And again, you see the whole world has this pattern of unconventional resources. It's no longer in the Middle East. It's no longer the Persian Gulf. It's no longer in Venezuela, which doesn't seem to have any. I'm sure that's not right, but there's none reported. So this is a worldwide blessing which is available. Here's the one chart that I want to show you about how hydraulic fracturing is done. There at the top, on the surface, you see a drilling rig. And it goes down in a vertical length 1 or 2 kilometers. And then they put a side passage on it, which goes out as far today as 3 or 4 kilometers. And along the path, through complicated ways of using pigs to block the way and perforating the side and injecting water, they make these side, at every point, they inject into the side of the formation, create these fractures by putting in the hydraulically fracturing fluid, and that's the way they cause the production to happen. This is not a mom and pop drilling operation. This is a very large and sophisticated technical operation. this is really, not responsible for me to show this. This is what a site looks like when it is getting prepared for hydraulic fracturing, drilling, and perforation. And what I want to point out to you is there's one, in this particular older slide, there's one well being drilled here and hydraulically fractured. Today there's been a lot of progress. There's several wells drilled from one pad. But what I draw to your attention is the number of trucks around that well site. Now, I want you to imagine living in a place like western Pennsylvania, a beautiful part of the country, where the roads are narrow and their communities are small. And one day, 60 hydraulic tank trucks loaded with hydraulically fracturing fluid come up with Abilene, Texas license plates on them. This is not a happy circumstance for that community. And while the person who owns this piece of property is likely to make a fortune from this operation, the people who live around him, there must be a light on this somewhere, the people who live around him may not. So again, the slide here stresses the magnitude of the operation, the impact that it's going to have, and I want to tell you, when this country starts producing this in broad numbers, 10,000 of these wells will be drilled a year. And they're going to be drilled everywhere. They're not going to be just drilled in, I personally don't have the same concern about a well being drilled in Texas or California that I do in Massachusetts. But people can differ. It's everywhere. It started off on a bad foot. And it started off on a bad foot, I hope I don't offend anybody in the audience, principally because of lobbyists and Washington lawyers who said, we do not need, oil companies, our clients do not need to tell you what is in this fracturing fluid that we are injecting underground. So first of all, I want to tell you that here is what the character is of that fracturing fluid. It's about 90% water. It has 1% sand, and here are the kind of additional agents that are around, added to this for a variety of Julia Child's purposes for having this fluid do what you want it to do. But the idea that a company or a company's representative could take the view, we're going to inject this in your county, in your farm, in your community, a place which has had no oil drilling before, and not tell you what the content of that is, it's just goofy. It's like shooting yourself in the foot. Well, they've backed off of that. They know that that's not going to work, and now all of the companies tell everything that is in their fracturing fluid, and they do it for two reasons, because their argument that there was intellectual property in the composition of the fracturing fluid was phony, and they saw that the public simply wasn't going to accept it. So that is a very important bad start, and still, if you look at the single thing which bothers people the most about hydraulic fracturing, they say the hydraulic fluid will go into our drinking water. So here is a chart of a lateral in the Barnett Shale, and here you see, carefully done, every possible fracking that has occurred and how far the fracks through the perforations went into the formation at the different depths. These are 8,000 feet, so that's what, a mile and a half, more than a mile and a half. And you can see that how far these injections went. Now, notice the distance from the surface, and there it shows the depth of the water table everywhere along the surface along this lateral distance. So you can see that there are thousands of feet difference. Very unlikely, in fact, unless, I'll come back to this, there's no way that that fluid which has been injected down there is going to find its way to the surface. So that whole issue, as emotional as it is, has been so terribly mismanaged. But it also shows you something else. It shows you what if we managed to, if we got better at directing each one of those fractures and knew that they were going in the most productive way. how much less water would we have to use if we could be more intelligent about making those fractures in order to do production? And the answer is a lot. You could be a lot less high utilization of water in hydraulic fracturing, and that goes to show you that the industry over time with field experience will make the advances so as to make this a much more efficient operation. Where do those, how could some of this fluid get to the groundwater? Certainly it's possible, because when you finish the well, you close it up and you begin to open it up for production. The first thing which happens is that you have a flowback of water that you injected in it, now coming back carrying some of the minerals which are present in the earth. And if you don't have a good completion at the top of your well, you could have a spill, and that can find its way into somebody's neighboring property in some neighboring place. So good completions here, good engineering completions here are critical. And while it is true that there's not much risk from this at depth injection, it is also true that there is a significant water risk if the completion is not done right, if the cementing job on the well or the casing of the pipe along the well is not done properly. There can be surface leaks which can go into the water table. My last point is another point about technology. This chart says there's a lot of difference in how each well, how productive wells are. Big variability. That says with engineering knowledge, making sure that you use best practice, best management on a well, there's a tremendous opportunity for much greater productivity per well, again indicating that you could have better effectiveness here with less environmental impact. That's it for the slides, please. So there are 4 environmental impacts I want to draw to, 5. I want to draw to your attention here in this when it's done at scale. The first is air emissions. The air emissions are of 2 types. They're from all of the power equipment which is on the surface when you are operating the drilling and injection equipment. There's a small and very important issue about the leakage of natural gas from the well completion. You will know that natural gas is, all of you I'm sure are as competent as John Holdren in chemistry. It's methane, but methane is a much more potent greenhouse gas than carbon dioxide. So even small leakage of methane is a matter of some concern here. So the air quality consists of the traditional controlled, regulated pollutants, but also a special attention to the volatile organic compound of methane because of its great greenhouse gas characteristic. Second is water. You have to purchase the water, acquire it. You have to get it to the site. You have to inject it. When you inject it, the first thing which happens is flowback water, which brings back some of the hydraulic fracturing fluid. You have to capture that water. You have to put it into a holding pond. The holding pond may service many different wells or many different paths. But after that, for the remainder of the lifetime of this well, which is 20 years, there will also be flowback water from the geology itself. And I should mention somewhere along the way, these geologies are quite different. The effects are the same. The opportunities are the same, but the particular geologies, like what's the water content, very different between the Eagleford in Texas and the Marcellus in Pennsylvania. But that water will also come back, and it will have some of the minerals which are in there. There's a curious chemical fact that the Marcellus actually has a tiny, tiny, tiny bit of radium in it, the water in the Marcellus. The Utica, which is underneath the Marcellus, doesn't have any. So the geochemistry is different here. But that water has to be held in and then something has to be done with it. Well, what can you do with that water? Because it's not drinkable, it's not usable. Well, you can do one of 3 or 4 things. One of the things you can do is, well, use it as injection water for the next well. That works fine as long as you're in a geometrically increasing world. But if you're not, if for some reason you're not always increasing, eventually you have more produced water than you have need for injection, particularly in a certain region. Secondly, you can go and inject the water, this produced water, into very deep wells, injection wells, which are regulated by the Environmental Protection Agency under a water disposal regulation. And you can do that. That means you have to transport the water by truck and then inject it. And in fact, in places like Pennsylvania, they have no injection wells. So they transport it by truck and put it in injection wells in Ohio. How long Governor Kasich will allow them to do that is an open question, or when he'll start charging real money. Or the third thing you could do is just let it go and fall in the fields, in the streams. But then you really are polluting those streams, and that's unacceptable, I think, in any part of the country. And finally, you can send these huge amounts of water to treatment plants, which have been built for an entirely different purpose, and ask them to clean the water up. I go through this because the Environmental Protection Agency is responsible for this, but so are all the state regulatory agencies. And they are at each other's throats. They are at each other's throats. The Environmental Protection Agency and many people in Washington, as expected, believe that one national authority is best. The state regulators, who have more real experience on the ground, know that there's a difference between the land in Arkansas and in Pennsylvania and in Colorado and in Wyoming, where in Wyoming they're much more worried about effects on visibility, dust affecting visibility. There's a huge quarrel about how this is best regulated. And let me tell you, that's not a good thing. Moreover, the Environmental Protection Agency goes at this by saying, what are the authorities that I have on my shelf that Congress has voted me, and how can I cobble them together to address this problem? I was talking to your distinguished provost a moment ago, who said, yeah, this is a tremendously interesting geotechnical question about how best to manage that water. And let me tell you, it's a big deal. We're going to have tens of thousands of these wells. But the Environmental Protection Agency works from the legislation on the shelf. It doesn't work from thinking this is a systems problem. It's not a systems engineering problem. So there's a big question here about how are we going to give industry the initiative to do better, where I believe all the prospects are they will do better and can do better. There's a big question about how authority should be shared on independent regulation between the states and the Environmental Protection Agency. And there's a big question about how this knowledge of regulation should be spread to the other countries who are beginning to use or want to use this technology. So it's a blessing. It has huge economic benefits to the country, huge benefits to the region, and eventually to the world, potentially. It has enormous geopolitical benefits. It doesn't make the world perfect. We're not energy independent, but we are less dependent on imported oil. We are not energy independent. We used to import, North America now, I don't talk about the US, North America used to import about 40% of its oil. When this thing goes up a couple of years from now, we're going to be importing less than 10%. And we may be even exporting. So it's a huge, but if you don't manage this environmental matter properly, this is not going to happen. The American people won't accept it. Well, what's the story for Stevens? What's the story for MIT? What's the story for universities here? There is a lesson here. There are lots of important lessons. And I just want to conclude with spending a few minutes about what this means for a university. First of all, you're going to wait a long time till you find a more contemporary example of where a technology change in society melds technical advance, economic incentives, regulatory and political challenges. This is an absolutely perfect, vivid, living example of it. Now, how well do we do at dealing with our students and carrying out our research in light of such kinds of problems? It's not only this problem, it's not only in the energy area, it's in healthcare, where I know you do have an initiative, it's in education, it's certainly in the issue of climate change, because none of what I've told you may be momentarily helpful to climate change because you're substituting natural gas for coal. But the natural gas itself produces CO2. So climate change is not addressed here. But it does say to the university, are we organized, especially those universities who care about innovation, those universities who care about working on their society? And I noticed that the slogan, not the word slogan, was, you're the innovation, huh? Tagline. MIT's tagline has got much more to do with making a difference on the community. But my point is, how does this look from an academic point of view? And the answer is we're very, I think, relatively, I'm talking now from the perspective of an MIT faculty member, we're pretty rigid in our disciplinary structure. Pretty rigid. Appointments and promotion go through departments. And certainly at MIT they do, and conventional departments at that. And we, incidentally, are living with a 50-year-old history of separating science departments from engineering departments. I don't know what that's all about. I know what it was about 50 years ago. But I could pull out any random faculty member at MIT and ask you, do you know whether this person's a professor of physics or electrical engineering or material science? Not a chance. So we're still back in those old disciplinary days. And I don't even know your distinguished provost, whether he's an engineer or a scientist. He says this is a geotechnical problem. Is he in Earth, atmospheric, and planetary sciences? Or is he in civil engineering? I don't know. But our university organizations are still looking backwards, not forwards on these problems, as far as I'm concerned. We could do more. We don't have to change everything overnight. We could try some experiments to do it. And I think that the lesson of this, what it suggests for education, is even more evident. First of all, students love this kind of problem. Students that I know love this kind of problem because it combines their knowledge that they have learned in their disciplines properly with the opportunity for making a difference in the real world. But we don't in our curriculum. We don't in the opportunities we offer them to hear from and learn skills from people that will allow them to put together the different disciplinary skills that you need to make one of these problems work. We never really do that heavily, and certainly not at MIT in their education. Again, I underline the enthusiasm that students have everywhere I go. Of course, if they ask me to come and talk about energy, the students who come are interested in energy, but boy, do I hear a lot of interested students. So I conclude by saying a big deal has happened in the United States, a big deal for the United States and for the rest of the world, and that is this explosion of unconventional oil and gas resources and production. It's a blessing, an economic blessing, and it's a geopolitical and foreign policy blessing. It's not a sure thing. How it will develop and all of the opportunities that can be realized or not a sure thing. But the most important thing is to be sure that you listen seriously to these environmental impacts because they are real. And somehow we organize ourselves to do better at them than just to sit by and wait and say, hope it'll get better. And finally, from this story and others like it, it really does say to the universities, there's so much opportunity to do things a little bit differently and really make a difference to our fellow citizens in making the world a better place. Thank you so much for your attention. Thank you.
If you don't mind, I'll use the microphone. Dr. Deutch, either it was because of your eloquence and knowledge, or my interest and the interest of the audience in the subject matter, or most likely both. This was one of the most fascinating talks we've ever heard. Thank you very, very much. It was very informative. We usually have a Q&A session after these events, and we had thought of doing it a little bit differently this time in order to make sure that all of the important questions are adequately answered. We had asked the audience who had signed up to submit some questions. I have a list of those questions, and I was reading them as Dr. Deutch was speaking. And I am sorry to say that you have answered all of the questions that I have on my cheat sheet. So if you're all right, I'd like to open the floor for additional questions that may have arisen.
John, the presentation was fantastic, but that leads to my question. 400 or 500 people here are going to leave very much more informed. There are a bunch of other people who make decisions in this country who don't know 1/10 of what you've said. Is there a way, or do you have a way in mind to reach at the state level and the federal level the people who will be setting policies?
The answer is absolutely yes. What really spun me up on this, I'm an oil guy. I mean, spent time, as was mentioned earlier, at Schlumberger as a director for 25 years. But what happened is that I was a member of Secretary Chu's, the former secretary's Energy Advisory Board, and the White House was interested in this question. And they kind of said, well, what we ought to do is to tell Chu to form a committee to study ways to reduce the environmental impacts. So I chaired that committee. And we produced two reports, one in August, the other one in November of 2011. And the impact of those reports was unbelievably big. I mean, it really did open up the eyes of legislators, many, many states, state regulators, certainly the White House, on these issues and how they and industry. I must say the courtesy and care with which the industry people interacted with us is very. So that report, I think, has set the tone. We're not there yet. We haven't moved as fast as I hoped we would, but I think it certainly did set the tone in all of my it's one of those cases, not the only case, where I saw an outside advisory group which really make a difference in towards informing people and telling them, you better pay attention to this.
A preface, I'm an alumnus of Stevens, and I'm also the class secretary. And one of my classmates from North Carolina, seeing this, asked me to ask you a question. So I'm being a good class secretary. He says, my question is, given all we know about climate change and its causes, what will the technologies you're espousing do to reverse it in time to make a difference? I'd like to hear an answer that goes beyond blame shifting, China, costs and jobs, and doesn't just kick the can down the road. So it's a tough question.
This doesn't do anything about climate change. I thought I said that. This does not do anything. It just gives you a momentary pause because you're substituting some gas for coal in the United States in the electric power industry. But generally speaking, there is no connection of this very beneficial and demanding opportunity and climate change. We have not addressed climate change, and I fear we will not address climate change, and the world will suffer both social and economic dislocation as a result of it. But this, what I've said to you today, has nothing to do with solving the climate change problem. It remains on the agenda. More complicated talk, which I can't give you.
I have a follow-up question, basically. So it's obviously going to reduce the concerns for energy security, and I assume it reduces political justification for diversifying energy resources. So is it going to be a threat for support of carbon-free technologies and climate change? And second question, if we take the carbon taxes serious, what is the prospect for cost of production? If you have a rising carbon tax, is it going to raise over time, or the learning curve will basically offset it? What's the floor for the cost of production?
I don't think that this, even if this spreads around the world, that it's going to make other countries who are now reluctant do anything about reducing their CO2 emissions. You say a carbon tax. I'm a great believer in a carbon tax instead of this complicated cap and trade system, because a carbon tax does something which a cap and trade system doesn't do so well. It puts revenue in the hands of government officials who could then disperse that revenue in a way that gets them support for the tax. So the real issue with a carbon tax is not the size of the tax or the tax, it's how you use the revenue. But none of this is going to happen. I've watched it now for a good 10, 12 years. None of it's going to happen. I was in the government when we did the windfall profits tax, when we released the controls on domestically produced oil and raised huge amounts of revenue by taxing the, quote, windfall profits that oil companies, domestic oil companies, got. And the way that was done was by taking that revenue and using it for purposes which Tip O'Neill liked. So I'm a great believer in a tax, but it's not going to happen. I wish it would. Whenever I'm in a meeting and I talk about it, they ask me to leave.
Thank you, Dr. Deutch, for an interesting talk. I have a comment and a question. The comment has to do with the slide that shows that 99% of the fracking fluid is pure water. I just want to point out that the same is true of raw sewage. But my question is a policy one. When at the beginning of the Bush administration, ancient history, before 9/11, the first major effort of theirs was the creation of the renovation of the energy policy of the U.S., and a large committee was formed, chaired by Vice President Dick Cheney. And it produced new rules for energy extraction, including for fracking, including exempting fracking from Clean Water Act rules, underwater, I believe they're called the Halliburton rules today, that exempt this activity. Just from a policy point of view, whatever your perspective is on those rules, what is the justification for extraction industries such as fracking and other energy extraction industries to be exempt from these rules when chemical industries, municipalities, et cetera, have to comply with the same kinds of regulations?
The short answer is none. On the other hand, I'm much more concerned about the fact, does the Environmental Protection Agency have the capacity to look at some of these questions like water management as a systems issue on a cradle-to-grave basis and really design a regulatory process which will permit and encourage improvements over time. So in the short run, I don't think exceptions for anybody which allow you to circumvent the rules are justified. And in the longer run, I'm concerned about EPA's capacity to really form a technically qualified and politically possible set of procedures that will lead to better water quality management for unconventional oil and gas production.
Hi, I worked in Schlumberger before for 3 years in directional drilling, but those processes not sometime an energy efficient. The energy efficiency of the process. So what's the future of making the extraction more energy efficient itself? Thank you.
Well, I think that if you look at the history of the big oil service companies and the national oil companies more broadly across the world, and certainly the large U.S. oil companies, they have become more efficient over time. their drilling, their use of all kinds of stimulation systems have become more efficient. And I'm very optimistic that with time and with experience, that this will become a more efficient operation, because efficiency of operation, profits, and lower environmental impact go in parallel in this particular case. So I'm optimistic. I can't promise it, but I'm optimistic that it will become better, not worse, as time goes on. And that's certainly the history of what the oil and gas industry is generally.
Dr. Deutch, if you recall, when nuclear energy was a growing industry, a lot of universities had nuclear engineering degree programs. And then over the course of the past approximately 30 years, there's been a decline. By contrast, there are a number of petroleum engineering programs in the country, some energy engineering programs in the country, but they're mostly focused in areas where there is oil or gas. There are a lot of them, for example, in Texas, Oklahoma. Do you, with this proliferation of activities in fracking, do you anticipate new degree programs in universities throughout the country?
Again, creating a new academic department with a label, even if it's petroleum engineering or something which is momentarily, MIT used to have a department of leather chemistry. So it's not that. And it's not that I want to avoid mechanical engineering or even electrical engineering or chemistry. My question is, how do you make those departments forces of change rather than citadels of protection? But I'm not looking for new departments of energy, new degrees in energy. I'm looking for ways of universities saying we want to address these complex problems with the skill sets that we are building here. I don't have any criticism about the skill sets which are being done. I'm saying, in my department in chemistry, God forbid that a graduate student would go and talk to somebody outside in another department, maybe in biology, but so you have to stimulate the interactions rather than create new departments.
Very good. Dr. Corfias.
Thank you for a great speech. You mentioned two things that I'm curious how they connect. You mentioned systems, and you mentioned that over 5 years, we dropped about $7 of savings, right? From $10 to $3 on the cost per million BTUs, right? So how much of those dollars, and in which way, can be reinvested to improve the system in the long run? And I think that will provide certain incentives once you start supporting technologies that also take care of climatic change.
The idea that poor people and old people, I'm going to go to an important place, Cambridge, Massachusetts, in contrast to the New York metropolitan area, are paying less for their heating of their homes. It is a big time effect on their income. I mean, it is a huge effect. It is a huge effect in all the big cities. And I think that's a good thing. So I'm a little bit hesitant to get Uncle Sam to put in more money to pull out a fraction of that dough and say that way we can spend more money on these new things that we want to devote more research, development, and demonstration to. Rather, I would like to see Uncle Sam take some money from the old research, development, and demonstration expenditures which have become entitled and shift it in this direction. So rather than diverting the savings which have accrued to the consumer, I would, in that sense.
But since money is fungible, one way or another, you're providing an avenue to treat or to address the entire system.
Yeah, that's true. That's true.
Good evening, and thank you. The deep water drilling failure of BP in the Gulf showed that there were huge systemic deficiencies in that technology, in the regulation of the wells, and of the coordination between the subcontractors on the wells doing the drilling. Has the petroleum industry taken lessons from that and are now looking at the fracking industry saying we need to be proactive and ahead of the curve environmentally and not simply responding to complaints? Or are they going to be like many other companies and just say, well, we don't have a problem until a regulator starts fining us or really putting pressure on us?
It's a very good question. In the case of Macondo, they saw the writing on the wall so clearly that indeed they have been hugely proactive in that regard. And they did something which even the nuclear industry at one stage thought was imperative, and that was to form INPO, the Institute of Nuclear Operations, whatever it was, plant operations, as a industry-wide self-policing technical organization to improve the safety of deep water drilling, okay? In the case of hydraulic fracturing, they have not been willing to move that rapidly or that far. Not because they haven't thought about it, not because they haven't listened, but because they see a regional strategy as being somewhat better from their point of view. But I keep on begging them, be more proactive, because I think that the regulators aren't going to get this solved in terms of public credibility, that it's going to have to be the public believing and seeing that the oil companies are becoming more proactive. So I would say they know the issue, they know what's on the table, but they're not as proactive yet as I would like to see them be, or as proactive as they were in their response to Macondo.
Well, first of all, I want, just as by way of a little background, I've spent my entire career, except for 3 years in the Air Force, in the energy field. And one of the things that I'm picking up anecdotally is that there's a shortage of really skilled people out there. And in some of the fracking firms, they're worried that, you know, that the human error is going to take a toll here. And when someone is untrained, this is where you get into bad cement jobs, you get into all kinds of leaks, problems. To what extent is the industry picking up on that? To what extent are they giving really in-depth training to their new employees?
It's a very good question, and it was a question that we addressed on this committee I was on the impacts of reducing the environmental impacts of unconventional gas. And I think that here you might have a little bit more comfort. Most of the hydraulic fracturing resources in this country have now been bought up by the larger companies. And the larger companies do have generally, not perfectly as we've seen in the case of BP, an ability to attract and train and assure the quality, the technical quality of their people. So I think you've pointed out to a very, very excellent point. I'm fairly comfortable, maybe I shouldn't be about that in North America, but let me tell you, if you want to go to other countries like Russia and ask how is it there, you know, because we are, an accident in one place can influence another. I think it would be a greater concern there.
Thank you very much for your presentation. Given your very impressive perspective, I was wondering if you could venture any comment about the oil in the Canadian tar sands and its piping down to refineries in the southern part of the United States. It may be another whole hour lecture, but I'd love to hear your sense of that situation. Thank you.
Well, I think it's a very unfriendly question. You know, the XL pipeline, first of all, let me just tell you for what it's worth. I don't think Obama's going to approve it, so you can, that's one thing. But I will tell you that I think that it's an example where the environmental community has chosen a subject to illustrate that we're not paying enough attention to climate change. because we're allowing heavy oil from Canada, which over its life cycle contributes maybe 6 or 7% more in CO2 emissions than light crude from Nigeria. We're allowing that to take place without putting a hammer down on it. So they're making a symbolic issue on that question, and I think doing pretty well with it. But if you go to them and say, well, let's make a deal, the people who use that oil will have to give a tax or will have to pay some emission charge. They're not interested in a deal on the XL pipeline. They're interested in the XL pipeline failing or not going forward because of the symbolic issue that it holds. So in some sense, the Canadians badly misplayed this in the sense of allowing a project to become such a poster child of symbolism about climate change. I might add that at the same time, we're allowing coal exports beyond, growth in coal exports enormously, because there's now so much coal available because we're not burning as much in our power plants. So we're really exporting vastly more CO2 than we did before. So it's not our finest hour. That whole debate is not our finest hour, but it is not going to get resolved by reason.
Dr. Deutch, let me repeat. This was an outstanding lecture. It was informative. It was insightful. It was extremely balanced in that you gave us an insight about the technologies and the science behind what's going on, and at the same time, the economic implications, the political implications of this that are of vast importance to us. It was like a beautiful movie that I watched for the past hour and 10 minutes, and I really didn't want the movie to come to closure.
Thank you very much.
There are many more questions, but there is a reception afterwards, so you'll have an opportunity to mingle with people and maybe answer some more questions. We have a small token of appreciation that's part of our protocol. I have a little plaque here that I'm presenting to you, and it reads, "Presented to Dr. John M. Deutch in appreciation of your contribution to the President's Distinguished Lecture Series at Stevens Institute of Technology, October 30th, 2013. And if you don't mind, we will take a photograph together.
Great.
So thank you, and this is for you. Thank you very much again.
Great.
Thank you. This was terrific.